Hello everyone, I'm Xiao Gang. Okay, in this moment, let's take a look at this corrosion angle. Because I personally like this barrage, I really like this barrage since I enjoy playing RTS games. For this corrosion angle, let's first see what it's like. You'll find that when you open it, it looks like this. And when your mouse has two modes, one is when you hold it down, it continuously adds a forward input mapping toward your mouse to drive the character to move in that direction. When you just click once, it will automatically move to this position. You can see, right, so these are two modes. I wonder if everyone can feel it. You can see, if you hold it down, you'll notice it doesn't generate this map indicator. If you just click once, right, or if you press it briefly, don't press it for too long, it still recognizes it as a click. Right, okay, let's take a look at how it's done. First, let's look at this content. First, this light work participants is the level prototype. And this is the character. These are some of the model assets inside. We'll ignore those. This is blueprint knowledge. Then we mainly look at this. This is a Niagara. We know that Niagara particles are very powerful. Basically, it is the system we will use for special effects in the future. A very powerful particle system. And this particle system, it will generate a mesh as a map indicator. This uses textures and materials, and we won't talk about how to write a Niagara example. We just need to know how to use this Niagara example. Okay. Then we mainly look at this top down. At the input section, actually we mainly look at this. There is a click event here, and here it has cancelled this part, meaning this part is cancelled. Then here, put this click event into this map. Maps the physical key of our left mouse button click. Then after this is done, you don't need to look at this map anymore. Then here we are. This is our game mode. The game mode actually does nothing. It mainly just specifies player control and player character. Let's first look at the player character. Precator actually doesn't do much either. It mainly specifies the plan being used. Yes, and there are also some simple parameters being modified. We won't worry about this either. And there are some things to note. This is the place. This Orient Rotation to movement. This parameter is quite important. When you are playing a shooting game, you might need the character to follow your mouse rotation and turn together. Or when you play something like some RTS type games, you might need the character to follow its movement direction. This involves the concept of targeted movement versus axial movement. That is, whether you have locked onto a boss or not. We'll just briefly mention it. This is something you need to know. So when should we use this controller? To control its rotation. And when should we directly make this rotation? Face this moment, that is a targeted movement versus an axial movement. This is a common piece of knowledge in game development. Okay, we have finished looking at this character. Then, let's take a look at this player controller. And this is quite important because it involves some core aspects. First, this registration. Registering this map does nothing special. Then this touch below is not open. Let's mainly take a look at how it maps the impro action, click event, and how it is mapped. Okay. Then, in practice, here first, this trigger will keep firing. This trigger mode means that as long as the mouse button is pressed during this process without being released, it will keep firing. Then, through this written function, it searches the scene for a ray cast by the mouse to see if it hits the floor in the scene. That's roughly what it means. So this one is relatively simple. It uses pure controller to directly go ahead without under cruiser by channel function. This is how the visual channel is selected here. Okay, so this returns the hit result and the hit location. After returning it, if we have a hit, we set the hit location as the cached location. Then we call this follow function. The follow function means you calculate your current and the two positions of the player's control pawn, and then they form a direction vector. Then it applies a push toward this direction vector. That's roughly the idea. Then, when we press the mouse button, it triggers the start. During the process of holding it down, this trigger will keep firing. So the effect you see is actually like this. A ray keeps shooting out continuously from the mouse onto the floor. Then the player follows this ray, calculates its current position, and receives an input movement amount, causing it to always move toward that location. Then when we press the button, it will stop the previous movement. You can see, right? So next, let's look at this for the remaining part. When cancel or complete is triggered. What this means is, whether you hold it down or just click, if you hold it down for less than 0.5 seconds, we consider it a click. So for a click, we will make it move to a certain point instead of continuously applying a pushing force. So how do we do that? First, we retrieve the latest target point that has been updated. Then we call the move_to method. This method actually calls our own simple move_to. Because this method is definitely this one, we can see that a controller is passed in here. This is actually a BP library, a blueprint function library. Here you can see AI blueprints helper library. You just need to pass a controller here. It will get the controller's form, then make it move to this position. If you are interested, you can take a look. Then I wrote some code. Then we close the code. And the most important thing here is this span system and location. This is very important because this generates a particle system. Note that this is Legro's function library. It is different from the path in the library because this one is specifically written into the library. You can see it is in the UEC function library. And here you only need to pass in the example system you want, the position required by the example. Then the location can be used to apply it. Of course, this thing definitely also includes the core modules of the Niagara example, right? Okay, so actually this blueprint, we'll just briefly go over it here. We'll mainly look at some details of 4++.